Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 6.5, solving exponential equations. We're going to be looking for 8 things to go in our notes. Let's go and get started with number 1. First thing we want to know is what property we're using. This is called the property of equality for exponential equations. It just says if two powers with the same positive base, so they have to have the same base, or b is not equal to 1, and they're going to be equal if and only if their exponents are equal. So this is a pretty easy example. If you have the example 2 to the x power is equal to 2 to the 5th power, then that means x is equal to 5. And if x is equal to 5, then 2 to the x is equal to 2 to the 5th. Same thing is true for here, and I maybe would like the algebra example better for you to explain. Remember, b has to be bigger than 0, but it can't be 1. As long as that is true, when you have b to the x and b to the y, x will be equal to y. So we're just basically trying to figure out how can we get our exponents equal to one another, and then also possibly solve for a missing variable. Let's go ahead and maybe take the time now to pause, and what I would do is maybe just copy down what's in these purple boxes. Oops. Just so you can see some examples, and then I'm going to show you how to try some of these on the next page. So for these, all you're essentially doing is just making sure first, do they have the same base? And it looks like all a, b, and c do have the same base, so what I can do is set exponents equal to one another. So that's exactly what I'm going to do here. So for letter A, I will have 3's as my exponent, so I would just write x plus 1 as my exponent on one is equal to 5 on the other. And then I would solve for x. I'm going to just subtract 1 from both sides. So letter A, x is equal to 4. The same thing is true for letter B. Again, I have the same base, so I can set my exponents equal to one another. Remember, if there's a number by itself, you can automatically assume there's a 1 there. So my exponents will say 1 is equal to 2x minus 3. I'm going to go ahead and try to get x by itself by adding 3 to both sides. So I have 4 is equal to 2x, which means x is equal to 2 for letter B. And then same thing is true for letter C. I have both 10s as my bases, so I can say 3x is equal to 2x plus 3. I'm going to get all my x's to the left side here because that'd be the easiest to solve for x. So x is equal to 3 for letter C. Here are 3 that you're going to get to try. It says solve the equation, then check your solution. Again, just make sure that they have the same base, and if they do, you can set your exponents equal to one another and solve. Let's go ahead and pause here so you can try 2, 3, and 4, and then once you're done, click play so you can check your work. So for number 2, you should have written 2x is equal to 6 because your bases are both 2's, so that means x is equal to 3 for number 2. For number 3, you can write 2x is equal to x plus 1 because we have both 5's as our bases. I'm going to subtract x from both sides to get them all on the same side on the left side. So I get 1x, or x, is equal to 1 for number 3. And then over here for number 4, I can still write this equation simply. 3x plus 5 is equal to x plus 1 because 7 is my same base for both of them. I'm going to move my x's to the left and my constants to the right. So I will get 2x is equal to negative 4, which means x would be equal to negative 2. Okay? So since we've had some practice with same bases, now we're going to look at some with different bases. And if you notice, you have a little bit of kind of a mixture here for both. You have, for letter A, we're basically just trying to figure out 5 to the what power is 125. That one's pretty simple because you can use a calculator to figure out how many times will 5 need to multiply by itself to get 125. And that's 5 to the 3rd power. So what I'm doing is just trying to make them be the same base. So once I do that, then I can solve for x. So in this case, simply x is equal to 3 for letter A. Letter B is a little bit different because I have a 4 and a 2, but what's nice about this 4 is that I can easily make it to be a base where it does have a 2. I know 4 is equivalent to 2 to the 2nd power, and I'm still going to keep the x on the outside. So now I have 2 to the second times to the x power is equal to 2 to the x minus 3. What I can do now is maybe go ahead and distribute or multiply my bases using the power of the power property, or multiply my exponents. So now I would get 2 to the 2x, because I just multiplied 2 times x, is equal to 2 to the x minus 3. And now I'm right back to square one, where I was working on those before, questions 2, 3, and 4, where I can just solve because I have the same base. So that's my main point, is to make them the same base. So 2x is equal to x minus 3. Again, get all my x's on the left side, so I get x is equal to negative 3 for letter B. And then letter C is a little bit different as well, because you have two different bases. The thing that they do have in common are 3's. So what I'm going to do is make this 9 to have a base of 3. I know 3 to the second power will give me 9. So I'm going to say 3 to the second, and then to the x plus 2. And then the 27, I can say would be 3 to the third power. And then I'm still going to keep the x. Okay, so you always want to keep what was still left over from your different bases. Now I'm ready to go ahead and distribute here. 3 to the second, and then timesing by the x plus 2. You're basically just going to distribute the 2 to the x and the 2. So now I'm going to get 3 to the 2x, 2 times x, and then plus 2 times 2 would give me 4. So 2x plus 4. So again, power of a power property just means I'm multiplying my exponent with the other exponent. That's basically just doing this right here, 2 parentheses x plus 2. Okay, where we're distributing 2 times x, 2 times 2. Same thing here, 3 to the third times the x power is going to give me 3 to the 3 times x. Now I can rewrite this as 2x plus 4 is equal to 3x, and then go ahead and solve. I'm going to bring my x's to the right side, because once I do that, I'll have my solution. 4 is equal to x. Okay, so here are a few that you're going to try. We're going to try 5 and 6 on this page, and then 7 and 8 on the next page. We're going to solve the equation. Make sure you check your solution. Again, make sure you get it to where you have the same bases before you start to try to write and solve for your exponents. Let's go ahead and pause here so you can try them by yourself, and once you're done, click play to check your work. So for number 5, we can rewrite this as 4 to the x is equal to 4 to the fourth power, because 4 to the fourth power gives us 256, so x is equal to 4. For number 6, I'm going to change this 9 to be 3 to the second. Still going to keep my 2x the same on the outside, and then I'll still have 3 to the x minus 6. 3 to the second times the 2x is just going to be 3 to the 4x. And then, once I have the same base now, then I can go ahead and set my exponents equal to one another. 4x is equal to x minus 6. I'm going to subtract x to get all my x's on the left side. I have 3x is equal to minus 6 or negative 6, which just means for number 6, x is equal to negative 2. Okay. Here are 7 and 8. Again, let's go ahead and try both of these. Number 8 might be a little bit more of a challenge question, but still try to do that one and see if you can come up with a solution. Again, let's pause the video here so you can try it by yourself, and once you're done, click play. So one way I solved for number 7 is I made both 4 and 8 be a base of 2, because 2 has those exponents in common. 4 can be changed to 2 to the second. So I have 2 to the second to the 3x. I'm going to go and change that as well. 2 to the second times 3x would be 2 to the 6x. And then for this one over here, I know 8 is an exponential solution of 2 as well. If I just write 2 to the third, and then still keep the x plus 1. If I distribute the 3 in my exponent, I'm going to get 2 to the 3x plus 3. Now that I have the same base, I can go ahead and write my exponent equation and solve for x. Oops, 3x. I'm going to subtract 3x from both sides. I get 3x is equal to 3, so that means x is equal to 1. For number 8, that was a little bit tricky because you now have a fraction, but you got to maybe think about in terms of reversing that fraction, what would that possibly look like before it was a fraction? And we can go back to those negative exponents that we learned earlier in chapter 6. 1/3 is the same thing as 3 to the negative first. So if I write that, 3 to the negative first, parentheses x minus 1. I can also rewrite 27 as 3 to the third. Okay, this is just one way of solving it. You could have solved a different way. Either way, I'm now going to distribute my negative 1 to the outside of my x minus 1. So I'd have 3 to the negative 1x plus 1 is equal to 3 to the third. And now I can go ahead and write my equation. So I'm just going to subtract 1 here. So I'll originally get negative x is equal to 2, but we can't keep x as negative, so what we're going to do is just basically divide both by negative 1, so that x is equal to negative 2 for number 8. Okay? Hopefully you're able to get negative 8 correctly, and if not, you're able to see a type of solution that you could use to find the solution for that one. That's going to conclude our notes today for 6.5. Thanks so much for tuning in, and we'll catch you next time.